In this video here, we'll cover the procedure that you'll need to follow in order to attach your GE C15D ultrasound transducer through the force measuring device. Now, throughout this video, we're going to assume that this ultrasound probe here, which is actually a 3D printed piece of plastic, we'll assume that that's the actual ultrasound transducer, and this is its cable. So first, you want to take your device and unpack it. So we'll attach the USB plug to one of the available USB ports on the computer. There's a couple located right here. Any port will do. Then we'll take our AC adapter and we'll plug it into an available outlet. Now the next step is to attach the ultrasound probe to the device. I'm going to demonstrate how we attach the ultrasound probe to the device. So first, we remove the top shell from the device, which is just attached by some magnets. Then we lift the top part of the clamp. We refer to this red piece here as the probe clamp. So first we pivot the top half of the clamp up. Then we insert the ultrasound probe. Now the ultrasound probe can actually go either this way or that way, doesn't matter. Choose whichever way is convenient. And we bring the top half down and we flip this little metal wire so it goes underneath this lip. There's a little lip in this plastic piece here. So we pivot it underneath of that lip, and then when it's underneath, then we go ahead and lock this latch here on the top. So after you've locked it, you want to take a look and make sure that the probe is centered properly. Looks like we've done a good job. So the next thing we want to do is we want to strain relieve the ultrasound cable here. And the reason we want to strain relieve it is because we don't want any tension that's applied to this ultrasound cable to show up as measured contact force. So let's take a look here at the force gauge on the screen. Go ahead and zoom in here. So that's the current force reading. Now, in the current configuration, if we were to pull on the ultrasound cable, we see the force change. And we don't want that because we want to measure the force that's applied to the ultrasound probe face right here. So we need to do what's called strain relieving. Now, in order to strain relieve the ultrasound cable, what we first want to do is create a little loop. This little loop is about this big. Next, we take our Velcro, this Velcro strip that should be attached to the black device cable, and we take that Velcro and we wrap it very tightly around the ultrasound cable. So now, any tension that's applied to the system will go through this black device cable, which is capable of supporting the tension, and it won't go through the ultrasound cable. And it's okay here if the loop kind of comes undone a little bit. The important thing is that while you're using the probe, you don't want to touch any of this cable right here. You only want to touch this portion behind the Velcro here. So now you can just go ahead and attach the top shell. You can put the bag over the system and you're ready to go. And the next step here is to attach the probe cover to the actual force measuring device. Now the reason we want to do that, in addition to sterility, is that there's a force sensor a small distance beyond this shiny aluminum piece here, and we don't want to get any ultrasound gel into the force sensor itself. That would cause it to give inaccurate readings. So we take our bag, what we first want to do is apply a small amount of gel to the face of the ultrasound transducer. And this will help to ensure acoustic coupling between the bag and the transducer itself. So apply a small bit of gel. It's probably good enough. I'm going to put our ultrasound probe into the bag. So there's a couple of things we want to ensure. First, you want to ensure that there are no bubbles present between the ultrasound probe and the bag. So I want to make sure that the gel is smoothed out and that we get good acoustic transmission through the bag. Once we've done that, we're going to take our rubber band and snap it around the bag. There's a couple of notches here. There's a few bigger notches here and some smaller notches here. You can use whichever ones you prefer to secure the bag over the probe. Now we want to make sure that the bag is relatively loose between the rubber band and the ultrasound probe. If it's not loose and we get some force pulling down like this, then our force reading will be less accurate. So we want to make sure that the bag is nice and loose the whole way around between the rubber band and the face of the transducer. Then we go ahead and pull the bag as far as we can so we can ensure that the cable doesn't get covered in ultrasound gel. So you'll note here that the loop that we created earlier is completely enclosed within the bag. So once again, any tension that's applied to this cable right here, we want it to go through the black cable and not through the actual ultrasound cable. So now you're ready to open up the program and start running the exam. Next, we'll talk about the last couple of things that you'll need to do before you begin conducting your exam. So to open up the force measuring program, we'll double click on the measure force program on our desktop. The program will immediately start running. So our probe is currently sitting on the table here and is not in contact with anything. And you'll notice that the contact force here still reads a non-zero value. It's about 1 Newton. Now that's probably due to either the way that the cable is velcroed in place, or perhaps the force sensor is warmed up a little bit since we plugged it in. That force that is currently reading is called the bias force. And we want to subtract that out from all the force readings during the exam so that we can get the actual contact force. So in order to subtract out that bias force, we'll first maximize the screen, maximize the force recording window. And then we'll see this advanced configuration panel shown here on the right. So we're currently using the plastic mock-up probe. So we've actually included a small button here that will click once and shift it to the left. And once it's shifted to the left, then it's acknowledging that we're using a mock-up probe. Now during most exams that you conduct, of course, you'll be using the real ultrasound probe, so you won't need to worry about this button at all. This button will reset whenever you close the program out and open it back up. So you'll see here at the bottom we have a bias force box. Now right before you're ready to begin conducting the exam, take the device and hold it in the air, not in contact with anything. So it's currently being held in the air, and we'll note that the force it's reading, the bias force, is about 1.7 newtons. So go ahead and in this bias force box, we'll type in 1.7 and press enter. Now you'll notice that the force reads 0, basically 0. It fluctuates very close to 0. So now if we press in contact with the patient, we see the force go up and go down as it should. There are a couple of other things to note here in the program. So in this circular area here, we have an aviation style display which indicates the angle of orientation of the device with respect to gravity. So we can look at the pitch angle. We can also look at the roll angles. We also have in this box right here the run number. So you might want to write down which run number corresponds to which exam that you've done. That run number here is also saved in the file name, and the path of that file is shown in this text box right here. And we'll talk about that more in a moment. Other interesting things to note are the record rate, how fast we're currently recording force. So now once you've subtracted out the bias force, you're ready to go ahead and conduct the exam. So once you're done conducting the exam, you want to stop running the program. So you can either press the stop button, sometimes that can take a while for it to stop, or you can press this small red octagon right here. Or you can just go ahead and X out the program altogether. But you want to make sure before you exit out that you've noted what that run number is. So next, it would be interesting to plot the data that we just acquired. So to do that, we'll click on this plot data program on the desktop. We'll double click on it. And then we'll enter in this run number, the run that we just executed, run number 164. In order to display the data, we're going to click on this small right arrow on the upper left of the screen. We'll just click it once. And we'll see on the top here, this green trace, we have force versus time. In these yellow and red traces, we have the pitch angle and the roll angle versus time. So this is a program that can allow you to rapidly check and see if the data that you gathered look reasonable. Another thing that you might want to do is actually look at the actual data, the file. So that's saved under this force data folder on the desktop. So we'll double click on that, and we can see this is run 164. So that those data are in this file right here. This is an LVM file. It can be opened with Microsoft Excel. So you need to find a computer with Excel in order to open up that program. When you open up your program in Excel, you can see that it has 7 columns here. And these 7 columns correspond to these 7 different parameters here that are shown on the screen. And these are also noted in the instructions. So in the first column we have the time, the second column we have the force, and then these other 3 columns, C, D, and E, we have some voltages that are measured from the accelerometer. You won't have to worry much about those. In the last 2 columns we have the pitch angle theta and the roll angle alpha, both in degrees. So every time the program runs, it records a single row, and it runs at a rate of about 40 or 50 hertz. So you have one reading about every 20 milliseconds going down to the bottom of the program here. To put the probe away, we'll simply follow the steps we talked about earlier in reverse. We'll take off the rubber band, protective bag, remove the top shell, undo the latch, take out the probe. Now what you want to do here is wipe off the plastic components here to make sure that no gel stays on the parts while it's being stored. Just a couple things to note here about packing the device up. Your AC adapter has a piece of steel that's epoxied to it, and this black plastic piece here has some magnets inside. So your AC adapter, when you bring it close enough, will sort of snap into place. You'll wind up your cable here, and when you close the box, you want to make sure that you don't accidentally pinch one of these cables in here, because if you do, it could sever the cable, and that wouldn't be good. So you want to make sure all the cables are nice and organized within the box. Secure the latches, then you're ready to go.